Hello, my name is GishniderGay, and I'm currently doing Project 4 for my COP3330 class, Object-Oriented Programming, and the topic revolves around threads and concurrency. So this specific project has us dealing with a simulation between two characters, whether it can be an eating contest, or a race, or just any form of situation. In this case, I chose a race between two heroes, well, anti-hero and hero, using speedsters, characters known as Quicksilver and Flash. So, before I get into the details of how I developed the values for it, let's start with something even before that, which was initializing the water break. So technically this was part 2 of the project, but it's the shorter part and it's easier to explain now than later, but it has its main uses. So the basis of this class is to essentially set up the resources that will be used by the threads later. And it's not something big and dramatic, but it does cause its own set of changes. So this class is set to be a synchronized method so that when I set up the threads for each of my contenders to do a certain action, or in this case drinking water, only one of them will be drinking water at a time, and they'll swap in between those two. So obviously I have it set to drink with the name and the integer being drink time. The name obviously going to be whoever is doing so, and the drink time being how long they drink it for. I also have a try and catch so that it can define the block so it can be tested for any errors, and if there is any errors that come, like an interruption from one of the threads, because the last thing we need is one thread going over the other. But in this case, it's basically set so when we have thread sleep kick in, that thread is technically the equivalent of it, obviously being asleep. But in this case, since it's used for the water break, the rest time that this thread's not working and the other thread that we have for the other contender is working, this will essentially be the water break for whatever contender is using it at the time. And it'll start off by saying that the person starts drinking, and then the thread will go to sleep for that period of time, whatever we set it to be, and then when it's done, it'll be done drinking. And as I said earlier, please note that no two threads will be doing this at the same time. Thanks to the synchronized method, only one will be doing it, and the other one will probably be doing another action during that span of time. So then we move on to the contender situation. So in this case, it's basically we're going to represent the characters, give them their values, set up their certain attributes that will be applied, basically putting together the fields necessary so that when we get to the actual application of it, they'll have the structures needed to put into play. So obviously the contender implements a runnable, which is basically the interface that will be implemented for these threads. So you're basically applying the threads, in this case multi-threading or application of concurrency. And we obviously have all our values, which is name of the contenders, the actions that they're going to be doing, the total actions. This aspect will be important because it'll be incrementally being added on as each individual does their certain actions. The max rest time, and I set this one for seconds, but people can use different spend time like milliseconds, or even hours, but that's up to their own choice. I obviously set a drink water. I've obviously applied drink water, which used the water class that we set up earlier in all of its values. And we also applied drink time, which will be the time taken for the contender to drink their water. So this one here is kind of special because this will be the instance where the thread will essentially kick in for a certain period of time. So we obviously have our first area where we have our public static boolean and when it says false. This here is basically just so that a winner won't be declared. There'll be no winner at the start of the whole thing. That it'll be set so that it's not an automatic win kind of vibe, which would be weird. But in this case, it allows us to let the race go on gradually. Obviously, we have a constructor to set up all the values, and attributes that will be used at a later point. Obviously with name, action, total actions will be set to 0. That is not negotiable, because essentially anything other number would basically be a head start, but obviously set to 0 for the start of the race, along with the other attributes. Now we proceed to our run method. This comes into play the moment we set up the run, implementing the runnable for its interface. This here is the factors that will come into play when we use our threads. And we obviously start off with, our random generator, which if you looked at the top, we have the input Java util random, which will be used to generate random numbers or timings for when we have our certain breaks or rest times or actions being applied overall. And we set this up with the generator being to be, equal to the new random. And we also have our while loops. In this case, this loop will keep on going and going and going until a winner is found. And within that section, we have the application of the total actions. So this part implies that with every total action that's done, obviously it will be the total action plus the action done at that time, and then for every time we loop and loop and loop, the actions will be added on to the total actions until we reach 200, which will then declare the winner. So it will incrementally keep on going, and when the winner is achieved, that's when it will set up the system to say that this winner wins the battle with such and such laps. After we reach that 200 or more, obviously the break will kick in to exit the loop because the winner has been declared. So then we also have our rest time, which then applies our random generator, as it will set the rest time to be for random amounts of time, but the maximum it will be set to whatever max rest time I place it in. So if I set the max rest to be 10 seconds, then the rest time could be within the span of 1 to 10 seconds, give or take. And obviously during that time, the rest time will be applying the thread sleep factor, which will basically set the thread to sleep, so it won't be active, it won't be anything for that period of time, or at least that period of the action being applied during the program. We also have our drink method here. Basically we're calling upon the drink method so we can simulate the water break. And since I said it earlier, this is synchronized, so that when this happens, each of the threads won't overlap against each other and all that kind of stuff. If one is having a water break, then the other one is probably doing something else, like probably resting or also running a lap or anything along the lines outside of there. If that was to be the case, obviously we have our exceptions to take care of those potential interruptions. Now we move on to the app itself. So in this case, we're basically setting up our objects to be applied so that when we run the program, everything turns out right. So we obviously have we set up our drink object for the use for the contenders. We also set up the contenders with their attributes that will be applied during the simulation. In this case, it will be having their names, the actions they do. It says action, but when it's quoted in the output, it'll be probably saying laps, and obviously your max rest time and drink time. Noted that the numbers are 30 and 5 seconds. Well, I set them to 30 and 5, so it's using seconds. If I was using milliseconds, I'd probably use like 300 or maybe 1,000 and something along those lines. But keep it small, keep it simple, and I'll show you how changing these factors can change the aspect of the race in and of itself. And then we have our respective threads, which in these cases which will set up the contenders to have their own specific threads so that they can do their own separate actions and the like, each doing their own thing, basically. And the thread starts are what apply and execute the run method that we had earlier. So when I said this was important, this is the section that will be applied to each individual contender. And obviously we also have to wrap it up with some contingencies in case something doesn't, make sure nothing bad happens. In this case, we have are two threads that will be applied. The join threads. These keep it so that that the threads complete their execution. So the whole process of the 200 simulations, the race, the rest time, everything, this makes sure that it doesn't end prematurely. And obviously with the interrupted exception being the application for that case. And then to wrap it up, once we get our winner, we'll wrap it up with the race has ended. So in this case, let's start the program to show. So in this case, each action shows that if they were to run, then obviously Kid Flash would do 25, Quicksilver will do 20. When they rest, he will Kid Flash rests for 30 seconds, Quicksilver rests for 40. They obviously have their water breaks. This is pretty much where the sleep will kick in. Same thing for the max rest, but it's already set up in the earlier section. And then we also have a drink time that will also be applied, which is applied for 5 to 7 seconds. Based on the data alone that's provided here, I could tell you that Kid Flash would most likely be the winner of this situation. So let's put the program into play. And oh boy, taking a minute. So obviously it shows all the steps that were taken. Obviously each of the Quicksilver doing is their laps. One's taking a water break. Note that when Quicksilver takes the water break, it doesn't say anything about the Kid Flash also taking a water break. In this case, when the Kid Flash does his water break, it doesn't say anything about the Quicksilver doing his water break. So they're obviously it's not placed interchangeably, or they're not crossing over. And this is just keeps on going until eventually we wrap it up at the bottom where Kid Flash wins with 200 laps. And Quicksilver is obviously drinking water, probably tired out from the race, and obviously it ends with the race has ended. So what would happen if I was to change the action of this 25 to 15 and maybe change the drink time to 10? Leave the other factors as is. Let it run for a sec. In this case, Quicksilver wins with 200 laps because, he was able to do more laps or actions and his drink time was less, along with other factors. So basically that's it. For the most part, I feel like there's some kinks to the program, so it wouldn't hurt if I can get some feedback on that case. Oh, you gotta be kidding me. Sorry about this. But for the most part, the program did what it was intended to do. This section provided us with the necessary details. It provided with the resources needed to have the threads have their water break, along with obviously the thread falling asleep, or allowing the falling asleep to simulate that water break. We also had the synchronization allowing us so that none of the threads started going over each other. We obviously had our fields and values. We also set up a constructor so that we could have them initialized with these certain factors that would be used later in our main application. We have our run method, which are basically is just an application of everything that's going to be in play during the race. And then obviously we have our Ultimate Battle app, which brings it all into view and allows us to get this output. So that's basically it for me. Hope you enjoyed, and thank you for your time.